Good day, everyone. My name is Salih Abdul Latif, and together with my colleague, uh, Mr. Siyam Ul Islam, we'll be discussing the D programming language as a part of our course ICS 535. So let's start with a brief overview of today's agenda. We will cover the basics of the D language, including data types, control structures like loops and decisions, and advanced topics such as concurrency and object-oriented features. We aim to provide clear examples to illustrate all of these concepts. So let's begin by a simple overview of what we're gonna discuss today. The D programming language is a multi-paradigm system designed to be compiled. It supports imperative, object-oriented, metaprogramming, functional, and concurrent paradigms. Files in D have the .D extension. It has a set of unique features like garbage collections, throw modules, and first-class arrays, among others that you can see on this slide. So here is our first program. We usually begin with the hello world in each programming language. Notice how we import the std.stdu module and use the write-len function to output text. This example will help us start exploring the syntax and functionality of the D language. So first of all, let's move to the basics of D. So in D, comments are used to annotate the code and are similar to those in C++ and Java and are ignored by the compiler. Identifiers follow common naming rules. These are specific keywords reserved by the language. Understanding these basics is the key to write effective code. And of course, these keywords cannot be used as variable names. So now let's move to the data types and variables in the D language. So D offers a variety of data types, including basic types like integer and floating points. Variable declaration is straightforward. You can see some examples here. First, you can see that the first example is float f, comma pi equals 3.14, which shows declaration of two float variables with one assignment. And you can see double D, which is the second example. This example only creates a variable with no assignment. Both are valid in the D language, and it follows a similar style to C++ and Java. So the data types in D are four types. So you have the basic types, the enumerated types, the type void, and the derived types. The basic types are integer, floating points, and characters. The enumerated types are, we're going to discuss them later within this presentation. The type void is basically a function type that returns nothing. And you have the derived types, which are the array types, structure types, union types, and function types. Some of these we'll explore today. So now let's move to the enumerations and literals. So enums, short for enumerations, are used in the D programming language to define a variable that can hold a set of named integer constants. By defining an enum, we make our code more readable and manageable. For instance, days of the week in this example consist of all days. Usually, these variables are giving the value of the index that they are stored in if they are created in a similar manner to the examples here. So let's move to literals. These are constant values directly typed into the source code. In D, literals can be of various types, such as integer, floats, booleans, characters, and strings. They play a fundamental role in programming as they are used to initialize variables or to provide values in function calls. String literals specifically are enclosed in double quotes. Any sequence of characters between double quotes, like hello world, is treated as a string. Strings are crucial for any program communicating with the user or that manipulates text. You have integer literals. These come in different varieties based on their base. So, for example, you have decimal, base 10, octal, base 8, binary, base 2, hexadecimal, base 16. A standard decimal integer is written as, for example, 212. Octal uses the 0 prefix, and it will tell the compiler that this is like an octal number, And you cannot use, for example, digits that are greater than 8 within it because it's octal, so it will only take digits from 0 to 7. Binary integers are defined using the 0p prefix, and the hexadecimals are using 0x prefix. These have legal and illegal parts, like you can see in this slide. Now we're going to move to in the deprogramming languages, structures or structs are custom data types that allows you to store multiple related items under a single name or a single type. This is specifically useful for grouping different pieces of data that belongs together. And we can see an example on this with this slide. So let's start with the structure declaration first. A structure in D is defined using the struct keyword, followed by a block of code that defines what the data structure will hold within a structure. Each piece of data that is within the structure is called a member, and each member can have a different data type. So you can see, for example, here the structure, we can define a book, as we said. The book has multiple features or multiple members. These are, for example, title, author, subject, and book ID. All of these are related to the book, which makes it easier to represent complex data types in every D program. So for declaring the structured data type, you can see that for declaring the structure type, it's similar to how you would declare any variable data type in D. The only difference is you would access it using the struct name dot the definition of the members within it. And you can see some examples here of like a working D program on this subject. Now let's move toward the next piece. Now let's move to decisions. Now the decisions are the structure that are considered with control statements, the most simple type of control statements that has no looping. These decisions are called if statements in other languages, maybe, or like a switch statements also. These statements have multiple types. You can see some types like if statements, if else statement, nested ifs, or switch statement, or nested switches. All of these are different types of control structures. The syntax, for example, for an if statement is similar to those in C++ and Java. As we can see, D is really similar in syntax to those languages. And you can see, for example, that it takes if, then the Boolean expression within the if, and then the block of code that will contain the statement to be executed. You can see, for example, here creating a variable called 10 and then checking if it's less than 20. Of course, 10 is less than 20, so it will execute the if statement and what's outside the if statement. And this is what we can see as from the output snippet below. Now, the if-else statement is similar to the if statement, but after the if block is completed, you add the else block, and you can see an example here. You have, of course, the if-else if syntax, and this will allow you to chain multiple if statements together that will run only. For example, here the only difference between if else if and using different ifs is that for if else if the compiler will stop executing after the first Boolean expression evaluates to true. So for example, if Boolean expression 1 is false and Boolean expression is 3 is the only one that's true, it will not run the first block, the second block, it will run the third block, and then it will skip. If Boolean expression 2 is true, then it will not run Boolean expression 1, run Boolean expression 2, then exit. So this is why we use an if-else if statement. Now for the nested if statements, of course, you can have ifs within ifs, and then which will help you create more complex logic using the D language. Now finally, for my part, I will represent loops. And of course, loops are control structures that contain a jump back to the initial start point. These are similar to if statements. The only difference is that you would rerun the code based on the Boolean condition. Of course, you're very familiar with loops if you have used other programming languages. And there are multiple types. So you have the while conditions, the for loop, the do while. right? And of course, it's similar as we said, like to C and Java. So the difference between, like for example, this slide contains the three main looping types: while and for and do while. The while loop will not create a variable, but will use variables already created within the code. The for loop contains an optional way of creating a variable and then incrementing it. For the while loop, of course, you need to create this manually, and for the do while, it will execute the code first and then check the Boolean condition, which is different than the while loop. Of course, as we said, this is very similar to C and C++. This will be it for my part. Now I will let my colleague take over to represent the rest of this presentation. Thank you very much for listening.
Okay, Assalamu alaikum wa rahmatullah. Thank you very much, Saleh, for your nice presentation. I am continuing after Saleh. I will start from function. And the function is actually a basic function definition consists of a function header and a function body. And it's a unit of code in any programming language. The function declaration is similar as C++, similar as C++ language. Here the syntax of the function. First, we need the return type, then function name, and then the parameter list. For this is the declaration of a function. So if we want to call this function, we have to call in this way. In this way, the name of the function, and we have to give the parameters. The flexibility in D language, there's so many types of functions, so many types of function. We will try to cover few of the functions. Here there is an example of a pure function. So why it is pure? Because there is a keyword pure before the declaration of this function. Before the declaration of this function. So here, pure function are the function which cannot access global or static mutable state save through their arguments. And here, this can enable optimize based on the fact that a pure function is guaranteed to mutate nothing which is not passed to it. For example, here there are few variables. There are global variables and the immutable state of a variable. So here yes, it is a pure function. When this function is called, for example, in the main function, this function is called, at that time, it cannot call the impure function. The right element is impure function. If you call this function, it will not work. But this will work because impure code allowed in debug statement. Here there is a keyword debug, that's why it will work. At the same time, these are the global state, and I is equal to x, that's a mutable state, and this is a constant global state. That's why this term will not work in this function, but it will work for the immutable global state. Here, I is equal to y. Y is an immutable. That's why. So if we we can use new expression is equal to auto variable is equal to new integer, and we can return the. Here we are converting the I and then returning the value, and here this value will be catch and it will print, and the value this function will print. This program will print the value returned from the pure function is 30. And there are different type of functions available in the D. For example, no-through functions, reference functions, auto functions, periodic function, in-out function, property functions. But for the limitations, we will cover only three types of function in this presentation: no-through, reference, and auto functions. So here is an example of each type of function. No-through functions actually do not throw an exception derived from class exception. No-through functions are convenient with throwing ones. No-through functions are conveyed from the throwing ones. Which functions are throwing? For example, here there is an example of this no-through function. So the no, we can identify or declare from the declaration, we have to write no through later on of the function declaration after the parameter is added here. So this is the function definition. If we go for this write ln adding, this will fail because write ln may throw. As this is a no throw function, nothing will be thrown. No exception will be thrown for here. Okay. So if we run this program, the output will be the value is 30. And the adding is coming from here, try. And this after the added value, the result will be returned as the parameter is passed from here. So at 10, 20, 30 will be returned from here. And another function that's called reference function. And this allow function to return by reference. Return by reference. A reference is type in D, one type. For example, here is an integer and integer B. Now we are calling this function. Reference function, it is declared here with ref keyword. So when we are calling this function, A and B value are passed, and here the parameter will be go. But parameter, when they are catching the parameter, it will be cast as reference. It will be cast as reference integer. So after the comparison, this will send the reference. For example, here first is 1 and second is B, and the condition is true. That means this first reference, it will be written here, and it will be uh, it will be added here with 10. So there the 1 and the B value will be the 12, the second value. Actually, this is not directly comparing the value. However, they're comparing the reference. So the second reference, the reference for the second one is greater. That's why it's written the second value and added with 10. And the third one is auto function. This auto function have so many flexibility, return value of any type. There is no restriction on what type to be returned. There is no type restriction. For example, this is a function and it's type auto, and the value here, it is passed at AB at AB. So the value A, this is integer and this is double. And after adding, here the integer is added with double, and this result is returned as double. This value is returned as double, as it is auto. So there is no restriction. What type? Anything can be, any type of value can be returned from this function. Okay, now we will discuss about pointers. A pointer is a variable. A pointer is a variable uh, whose value is the address of another variable. So here is the syntax. If I want to declare a variable and that the type is pointer, first we have to declare the data type. That means there are integer, double, float, and character. And are the variable names. This means this integer, this is pointer sign, pointer ID. It will hold the address of integer. That means pointer to an integer. This is how we read pointer to double, pointer to float, pointer to character. So this is how in the memory the data are points. For example, the value. This is a variable. It has a value and it has an address. And this address is stored in the pointer variable here. And here is the example. For example, it is integer variable and whose value is 20, actual variable declaration. And we have also declared a pointer and that type is integer. That means pointer to integer. And this IP can hold any variable's address that is integer. Now we are assigning the address of this variable and var sign, that means storing the address to IP. That means this IP now holding the address of var. And this is similar as the C and C++, similar type of working here. So write ln. So the value of the variable, this is the value, it will give 20. And as IP is holding the address, so if we print IP, it will give the address of 20. So in different times, this value will be changed as it will be stored in different places. And after, if we print pointer IP, that means value in IP, that means value in this location, and this will be 20. There is another type of pointer that's called null pointer, and it is always good to practice assign the pointer null to a pointer variable in case you do not have exact address to be assigned. This is done at the time of variable declaration when we declare a pointer type of variable. So if we assign a null value, here you are saying first we are declaring a pointer and then assigning a null value. This means this pointer is uh, only creating a space to hold an address of integer type of variable, but we don't know the value. That's why this null pointer is used. So if we print this value, the output will be the value of the pointer is null. So let's move on to the concurrency. Concurrency is making a program run on multiple threads at a time. An example of concurrent program is a web server responding many clients at the same time. And concurrency is easy with message passing, but it's very difficult to implement. Now let's learn how concurrency works in D. The basis of concurrency is a spawn function. Spawn, that's by default here. So the function spawn takes a pointer as a parameter and start a new thread of that function. Here you can see an example here. This is a main function. In the main function inside of loop, we have called a spawn function. That means it will create the threads. And for what it is taking? It's taking a parameter of another function. And what's the name of that function? Is worker, and this function is declared here. So it's taking the parameter, and what it will do, any operation. For example, here inside of worker, there are so many operations are done, and included other function that may call will be executed on new thread. It will open a new thread. So if we run this program as here, we are saying 1 to 4. So this thread will be created 1, 5, 2, 6, 10, and 3. This thread will be created, and after this, each of the thread, it will create another thread here. The worker threads are also will be here. And the message passing, this is the example of another function that's called message passing. Each of the threads, these of the threads, they are independent. Each of the thread, nothing is going or nothing is out inside of this thread. But here, each of the thread can communicate. So that's called message passing. Here, the spawn function taking the parameter of function worker, that means it's creating a thread of this function. So it may send the message, but where it is called, for example, this spawn function is called from the main function. So here, after running this function, they wait for a message. For example, it goes from this line, wait for a message, waiting for a message. And while it receives hello from the another thread of this function, uh, it says received hello, and it will initiate at 100 milliseconds interval. So these are the concurrency in D language. Now we will go to the brief description, or very briefly we'll go through, try to cover the object-oriented part of D programming language. Object-oriented paradigm, the D language is very much similar as C++. As in C++, declaring a class, it takes the keyword class before the name of the class. This is an example of a class, a small class. The name of this class is box. And here the type of the data, that means access modifier, public, private, protected. The same thing is in the D language as well. So these are the variables. These are the variables, and all the variables are public. And this is a class. So if we want to create the instances of a class, now we have to declare the instances of this box class. For example, how we can declare? We have to declare in the main function. This is the class and this is the main function. Now this box is this box type, class is the box type, then box one, new box, similar as C++. So here we are defining box one and box two. These are the object of this box class. That means box one and box two are type of box class. All of the boxes, that means box one, box two, they have the similar kind of structure. And the double volume is 0.1. That's the variable declared in the main function. So if we want to access each of the variables for the object, we have to access in this way: box.height, box1.height, box1.length, box2.length. That means it will create two replicas of boxes, box one and box two. For box two, box one, These are the heights and length and breadth. And for box 2, these are the height, length, and breadth. So if we run the program, the volume will be for the box 1 as the values are here. So if we want to calculate the volume, so we are accessing these variables, and this will be the output for this program. Similar as C++ and similar as C++, it has a constructor and destructor too. All the declaration of constructor and destructor is similar as the C++. Here we see the how to declare a constructor, but actually not similar. There is a difference in C++. What we do, we declare a constructor by the same name of the class, but here the difference is we have to use this and following the first bracket. So this is used for constructor. That means this portion used for construction. And why we use constructor? Constructor is actually used to initialize the values in the object. For example, here the line type of variable. This is the line class. This is the object of line. So when this line is called, this constructor will call automatically. So first, the output will be as here it is calling. That means this will call automatically. This will execute and it will print. Object is being created, and then the second line comes from here, the right line. As we are creating a constructor, similar, we have to create a destructor. In Java, uh, the destructor is created automatically, but in C++, we have to create the manually. In the D language is similar. So how can we declare this destructor? We have to use this delta symbol before the constructor. It will free the spaces, free the memory that was occupied previously when the constructor was created. One of the important concept of object-oriented programming is the inheritance. Inheritance, and this is one of the most important concept of object-oriented programming. And the similar here it is also similar as C++. How we can, what's the concept of inheritance? The concept of inheritance is able to reuse the content of another class by another class. The class who is using the content of another class, that's called the child class, and whose context is being used is called the parent class. Another way, this is one is base class, another is derived class. Base class uses base class is used for main declaration, and derived class uses the content of base class. For example, here there is a class here. There is a class. This is the base class and this is the derived class. This is the base class and this is the derived class. So base class, we have declared a shape class. It has two functions, set width, set height, and the variables are protected. In the derived class, this is the symbol of inheritance. This is the rectangle class and this is the derived class, and this class is using the shape class, and that's why this colon is used to notify that there is an inheritance. That means this rectangle class inherits all the properties of shape class, and it has its own function get area. So when the main function, when from the main function, we create an object of rectangle class, that means rectangle. So now the rectangle class has three functions. This one, this set height and set width. Everything can be accessed to rectangle. And this is the flexibility of object-oriented programming. This is similar as C++ in here in D as well. Then we are going to use the interface. In interface, actually, there is only a similar concept of the inheritance, but here there is only function name and declaration. So here this is a base class. In base class, there will only be declaration, and the derived class, if there any other derived class use this base class or inherit this base class, they can use or they can implement their own implementation for these functions. So interface only gives the declaration of the functions, and the derived class, they give the definition of these functions here. So this is an example here. So this is set width and set height. And here is the definition of these two functions. And if we call rectangle interface, and if we create the object, sorry, this is a rectangle class, and this class is using this shape interface, then we can use these functions here. And the output of this program will be 35. And here is an example of abstract class. Here is an abstract class is another important object-oriented concept. The abstract class is that class whose object cannot be declared. For example, here we have a class called person, and before that we have a keyword abstract. That means we cannot declare an object for this person. Then what's the meaning of declaring this class? There is another way to access the properties of this abstract class. That is, we can inherit the properties of this person class, and then we can use the properties of person. Here, this is the abstract class person, and we have another normal or general class employee who is inheriting person. Now, in the main function, we have declared an object of employee class as the EMP, as EMP is inheriting person class. Then that's why we can access the contents, that means the variable and the functions from here in the main class. So we cannot directly use the person, but we can use this person through a derived class from the main function. And this is similar concept in the C++. And this was our in general overview about the D language. And there are so many flexibilities in the D language as well. For the timing, we have covered these parts of the D language, and there are many more flexibilities of the D language you can explore to learn and use D. Thank you very much. Thank you very much again.
Thank you, Siyam al-Islam, for this excellent presentation. Now let's conclude our presentation or tutorial with a 5-question quiz. This quiz will test your knowledge about the D language. So for the first question, what is the default access specifier for members in a D class? In other words, if not specified, what access specifier or modifier will the D language use for members of your class? The answer is, unlike C Sharp and Java, it will actually use the private access modifier. And this is interesting because usually other languages use the protected access modifier, but for D, because it's safer and it does not assume that members without explicitly mentioning it will be inherited or used in other instances of the class. Now, let's move to the second question. How can you prevent a class from being inherited in the language? So, if you have a class and you want this class to be the final instance, or you don't want anything to be inherited from this class, how can you do that? The answer is you use the final keyword, just like how you would do for any other variable. And here's an example. So you would have the parent class of base, and then you have the final class of no inherent. This no inherent class will just won't be you cannot use it as the parent of any other class. Now let's move to the third question. How does D handle exception handling, and what is unique about its approach? Usually for languages, it try catch, for example, for Java and C Sharp, it try except for Python. So what does D use, and what is unique about it? Well, D actually uses the try catch finally syntax, similar to a lot of other languages, but it has an extra feature. This feature is the scope guard statement. So it has different scopes for the success and failure and exit, and this is very good when dealing with variables that are defined within a certain scope, and makes it much easier than defining global variables, because you only need to have them in the specific scope they are in. Now, let's move to question 4. Now, what are mixins in D and how can they be used? So this terminology of mixins is special for D and maybe some other languages, but it is mostly known for the D language. So what is it, and how can they be used? Well, for the mixins are metaprogramming feature that is in D, and it allows some type of metaprogramming, so you can generate code in runtime and make it part of the executed code. This is very powerful, but at the same time very dangerous, because this can cause some security issues. But for example, if you want to do this, you can do something like this example. You can have some type of template. This is a string mixin. You can define this function int multiply by 2, and then you can use the mixin, and within runtime you can create a new object, and within this object you can create this multiply by 2 mixin, and this will do it within runtime, and it will create and generate a code and compile it and use it within the same class all at runtime. Now, for the final question, how does this support functional programming, particularly with lambda expressions and higher order functions? As we studied in our course, or as you know, the functional programming paradigm is very useful for concurrency, and has a certain amount of features. These features, are a lot, but mostly functions in the D language act as mathematical functions, and they have no side effects. So how does D support functional programming? Well, actually D supports functional programming through lambda expressions, and higher order functions and immutable data types. The lambda expressions in D are defined using the arrow syntax, and function can be passed into other functions, which is the higher order function part of the D language. This is a specific syntax. That's all from us today. I hope you learned something new, and that will be it. Thank you very much for listening and taking the time of your day to listen to us today. Thank you.